Hello, it's time for another big project. Let's make a top-down role-playing game.
Without a doubt, the most popular request I have had for a project is to create something along the lines of a Zelda game. Now, I love Zelda, but I've always been a bit more of a Final Fantasy fan, so I thought it would be an interesting project to try and merge the two together. So we've got sort of Zelda gameplay, battle and exploration dynamics, but we've got a plot given in the style of Final Fantasy. And this is what we've come up with so far. So I'm currently controlling this little character walking around the map, and you can see some effort has gone into the graphics. Now, all of the graphics have been created by the One Lone Coder community from people on the Discord server. And they're all still a work in progress. Because of this is a big project, I don't have the time or resources or the skill, frankly, to create all of the graphics necessary. I've needed other people to do that for me. Anyway, so we're looking around the map here, and of course we've got some collision detection. We can't crash into the buildings or trees. And one of the things we can do is enter the other building. We can see the tile set has changed, and again we've got collision whilst we control the guy around. We can exit the building, and we go back into the town level map. All familiar stuff. But for me, RPGs aren't just about walking around finding things and fighting enemies. I like story-driven RPGs, and so a lot of effort has gone into this project to develop a system which will allow us to deliver a story to the player. So here we've got another character, and I'm going to interact with him by pressing the spacebar. And we can see straight away the character orientates to a known position, and some dialogue starts. In fact, this guy wearing an orange t-shirt is me. Hello. Let's make her. Oh dear. And the character, we've called him Witty for now. Don't know if that's going to stay or not for the end game. And so I've still no control, but the script engine, I've been calling it the theatre engine, has taken over, and it's moving the characters around and presenting the dialogue. I've got control again now, and I'll go and I'm not going to talk to myself, oddly, just yet. I'm going to go step outside, because one of the important things with a game like this is persistence. But having that conversation has triggered other things to happen. For example, now I've got the introduction of two enemies. Now, before they come and kill me, I'm going to go back inside. I'll finish off this conversation. So we'll talk to the character again. It's no good. I can't make a video. Why not? Well, two things really. Firstly, I've lost the source. Secondly, I've lost my glasses. So this is the start of sort of two additional quests. And Witty, because he's a helpful, resourceful type of guy, jumps up and down and says, I can help. And again, I've got control over the player. So that's all handled by this theatre engine in the background. We'll go outside and try and take on these enemies. So the enemies have a limited amount of AI. At the moment, they just sort of follow me in a Terminator-style mode. But they have to abide by the rules of the map too. So you can see they can get stuck on solid things. There's nothing clever going on here yet. And we'll see throughout the course of this project that we can really sort of fine-tune things on a per-object level. Because even though this is a video about an RPG, it's really a video about object-oriented programming. Let's take on this skeleton. So we've killed one of them. And let's kill the other. There we go.
This project is far too big for a single video, so it will be split over several videos, and I'm not yet quite sure what the release schedule will be. I'm still actively developing this project. Now, to be different to a lot of my previous videos, this one is highly object-oriented. And that's because I think people aren't really exposed to object-oriented programming through most of the stuff that I've been working on. Yes, we've used classes and structs, but we've never really used them in any form of anger. An object-oriented programming approach is ideal in this situation because we've got lots of objects in the game that interact with each other in different and customizable ways. Also, even though I'm responsible for programming the engine, the rest of the community is contributing in terms of graphics and maps and quests, or at least they can do if they want to. And so this means we want to find a form of separation between the core and what we'll call the assets. And this is important because if the graphics or the quests or the objects change, we don't want to have to hard code changes into the core engine. An individual's approach to object-oriented programming is polarizing. There's no doubt about that. Absolutely, the way I am going to show how I have used object-oriented programming in this video is going to upset somebody. And so a little personal disclaimer. This video is probably not going to be an example of best practice when using object-oriented techniques. But nonetheless, for the most part, I think you'll get a really good understanding of how object-oriented programming can really enhance and partition your development process. But I will be breaking some rules. Now, before we get started, I've got three other things to say. Firstly, I'm not going to be putting the source up at the end of this video. I'll put the source up completed at the end of the project. Secondly, at the end of the project, I'll also put up a compiled version of the game. And thirdly, I won't be showing every line of code necessary in detail. And you'll see why. Object-oriented programming has a lot of repetition. And the size of this project, if I was to show me typing out every single line, it would get quite boring. And so with all that out of the way, let's get started.
This first video of the series is really about the structure of the project, and you can't start a big project without having a think about what the requirements are. And for me, the most important requirement of a role-playing game is to tell a story. We also want to explore. And this is traditionally split into towns and dungeons. We know that just walking around isn't enough, so we probably also want to have some battles. And as well as just battling, exploring, and enjoying the story, the player also needs to feel rewarded. So we need some items, weapons, and power-ups. So let's just have a little bit more of a think about telling a story. Well, we know a story is going to have to involve some sort of plot. It's got to be compelling, it's got to keep the player engaged. And we're going to use the plot and the rest of the system to develop an atmosphere. Something that will really absorb the player's interests. In order to tell a story, we're going to need characters. And the cast of characters, in some way, needs to be scripted to form cut sequences. To facilitate exploration, we're going to need maps. And these could be things like towns and dungeons, the sort of stuff you saw at the start of the video. We also probably want hidden stuff, so you get that real buzz from finding something that you think nobody else will have found. We're going to need a way for the player to move around these maps, so we're going to need navigation. And adjacent towns and dungeons can simply load to each other, but we may also want to go from one town to another, so perhaps we also need a world map. Battles are important too, because that's how the player is probably going to grow their character through the game. So we're going to need an array of enemies, so different enemies, and we'll probably want the enemies to behave in different ways, so we're going to need some sort of behaviour AI. Battles also need to be balanced, and this might take a bit of fine-tuning. It's no good if the first enemy of the game comes and kills your character straight away. But they also need to be fun. They can't be cripplingly strong, they can't be boring and mind-numbing button bashing. To reward the player, we're also going to use items, weapons and power-ups. And so this invariably forms some sort of treasure system. It could be gold, it could be exploring chests. I think more commonly these days it's known as loot. And by power-ups I don't mean turning the character into some unstoppable force. It's usually an upgrade to their weapons or armour. But of course we're going to need something to keep track of all of this, so we're going to need an inventory. And it's quite possible that the player is going to collect lots of loot in the game, so we're going to need somewhere for them to get rid of it. We'll have some shops. It's interesting to see from this list already that we can start to identify what's game design and what's engine design. So for example, the plot here, that's a game design thing. The game engine has to facilitate the plot, but ultimately it's the game designer's role to come up with the story. And the same goes for creating the atmosphere. What does the art style look like? What's the music like? And how do those things tie into the plot? The characters is a bit of both. Of course, that's plot and atmosphere. But what I think is important here is that we're going to have multiple characters. So perhaps that's an engine design thing. And the same goes for cut sequences. We need to think of how do we structure an order of events to display animation, dialogue, interaction to the player. When we start thinking of maps, we know that the game engine must support the loading and transition between maps. But also the layout of the maps becomes a bit of a game design thing too, so we'll highlight that as game design. And certainly hidden things, that's purely a game designer thing. However, moving between maps is probably an engine thing. There'll be something on the map that says, I must load another map. And certainly the world map is an engine thing too, because even though the world map will be designed by the game designer, it's basically the central hub through which the player can find all of the other dungeons and towns to visit. When we start to look at different enemies, that implies that we're going to need assets which behave and do things differently. They look and feel different to the player. So that's an engine thing. And how their behaviour is implemented is also an engine thing too. You wouldn't expect the game designer to necessarily decide on the maths and physics involved to implement a particular AI. So we're going to leave that in the engine column. However, tuning of the enemies, that certainly is a game design thing, because that needs to fit in with the plot and what the expected experience level of the player is. And making the battles fun, well, that's probably a bit of both, but that's still a game design thing too. The types of treasure and loot, well, that's certainly game design. That's where you can potentially inject a little bit of humour into the game. And the nature of the upgrades is also game design, because we don't want to give the player the most powerful weapons right at the start of the game. However, the upgrades have a minimal impact on the engine. All they're going to do is increase or decrease a stat. Supporting and maintaining an inventory, though, that's an engine responsibility. And so is implementing the shopping system.
By drawing an admittedly blurry line between the game design and the game engine design, we can start to see how to partition the project.
The player will mostly be interacting with the game through the top-down view, and so that means we should probably start there. So let's consider we've got the player character. And the first design decision I'm going to make is that everything is based on tile maps. And everything that's interesting in the game is going to be 1 tile wide by 1 tile high. Now, I know that my player character can move in the compass directions, north, south, east and west. But some sort of environmental map will say where the player can and cannot go. So, for example, if we've got, say, a tree here, and a tree here, and, say, some more trees, why not? Yes, those are trees. Told you.
I'm not very good at art.
Well, we know that these tiles, well, these are solid. So even though they've got a graphic in them, we'll mark them with a red outline to say that these tiles are solid locations. The player cannot enter that tile. And so this starts to yield some information about what we want to store in our tiles. We're going to need an ID that represents the graphic that's displayed, and we're going to need something to say whether it's solid or not.
Now, some of you will have seen some very similar ideas in the Code It Yourself platform game, and in fact that's where I'm going to start, because I'm not going to reinvent the wheel. And if you think about it, if Mario didn't have gravity, it would be a top-down walking about game. Or if Zelda did have gravity, Link would be falling to the bottom of the screen all the time. They're actually the same thing. So I'm going to exploit the fact that I've already created a tile map system with collision detection for this top-down role-playing game.
So this means we have a map in the background with static solid objects in, based on their cell location. This would imply then that anything that interacts with the map, for example the player character, is a dynamic object. It can move around. And this is where we stopped it with the Code It Yourself platformer, because we assumed we had one dynamic object, which was the player character, and the rest of the map was solid. However, in the RPG, we're probably going to have multiple dynamic objects. So let's say we've got a non-playing character, an NPC. Well, we know that for cut sequences and other things that we probably want to move them around, so that makes them a dynamic object. So let's start having a think about what a dynamic object is. Well, we know that it's going to have a position somewhere in the world. And because it's dynamic and we have a position, it's very likely we're going to need some velocity too. We don't know yet what the full extent of the dynamic objects will be capable of doing, but we can probably make some assumptions. For example, dynamic objects probably cannot pass through all solid tiles. However, what if the dynamic object was a ghost? Well, or a bird. It could effectively fly through the solid tiles. So I'm going to create a flag which is solid versus solid objects. So that's sort of things in the map in the background. But then I don't want my player character to be able to walk through other player characters at some times. That could be quite rude. So I'm also going to have a flag which is solid versus dynamic. And we'll see by manipulating these flags that we can extend the range of behaviours of what the dynamic object can and can't do. But let's extend this idea of a dynamic object even further by considering that all dynamic objects are interactable. And I think this is an important distinction to make. So if my player character walked over to the NPC and interacted with it, something happens. And so this makes me think that somewhere we need to handle an event which is an on-interaction between one dynamic object and another. At the moment, I'm really throwing ideas at the screen to see how things come together. We may change some of this in the future, but for now it's just to get us started. Now this does raise a slightly curious question. How do we handle, for example, interactions with things that look like scenery? So let's say we had a signpost in the map. Well, that signpost is indeed part of the map, and it's solid. The player can't walk through it, so it becomes a solid tile. But we could also place on top of this solid tile a different type of dynamic object. And this dynamic object will have all of these properties, but most of them we ignore. What we care about is the interaction. So when the player interacts with this dynamic object, it displays, I don't know, the name of the town or the direction to the shop. We may also have other types of non-obvious dynamic objects. For example, here. And this one might be slightly different, that instead of the player choosing to interact with it, the player interacts with it by walking over it. So in this case we would set the solid properties of this dynamic object to false. It's not solid, so my player can walk over it, but when the player does walk over it, there's an interaction. And in this case, this interaction might be to go and load another map. Let's say I have another type of dynamic object. In this case, it's an enemy. The dynamic object in this case is controlled via a behavioral AI. So something else takes control of the position and velocity components to give some sort of movement behavior around the map. And we can make an assumption that if our player character interacts with an enemy character, then it's an attack of some sort. But if our player character interacts with the NPC, then it should be the start of a conversation. It's a friendly thing. And the third option here is, of course, that the enemy character can choose to interact with the player, which again is an attack. So I think at a fundamental level, we need to decide whether things are friendly or not. So I'm going to add another flag here, which is the dynamic object something that is friendly towards the player? So already we've got quite a few different things. They're all essentially dynamic objects that can interact with each other, but for example, the signpost is something static that cannot be moved around and cannot be walked over. The NPC is again something that can move around by itself, as is the enemy character that can use a behavioral AI to move it around and decide what it needs to do. And some dynamic objects are invisible to the player but perform functions because they're still interacted with in one way or another.
So even at this stage we can start to think about a class structure which would be suitable for our role-playing game.
We know we're going to need a map. And our map is going to have many tiles. Now, I'm not using any formal notation here, but typically if you're using something like UML, you'd put a little star here to say this is a one-to-many relationship. We also know that we're going to have something that's dynamic. And we can start to tell already that something that inherits from dynamic is going to be a creature, i.e. something living that's moving around. So for inheritance, I'm going to draw an arrow that way. And we also know that something else can also be dynamic are things like the teleport panels or the signpost. So they're in some way some other type of interaction. I don't know what we'll call these yet, but that also is going to inherit from dynamic. And as creatures go, we may have something like the player, which is a type of creature which is dynamic. And we may have a particular NPC, which is again, some type of creature. And so for interactable objects, we may have things like, yes, the teleport, or the signpost. And you might be thinking, well, why don't we just create teleport, signpost, NPC, and player as all separate things? Well, the reason being is we can make all of our control and management code much simpler if we classify them all as the same type. And this is really where the power of object-oriented programming comes in. So let's say in our base class, which is dynamic, we have a function which is onInteract. When we implement a player subclass, well, the player doesn't really interact with itself, so this probably doesn't do anything. However, when we override the onInteract function for an NPC, something may happen that's related to the current quest, and we'll talk about quests in a later video, but it could, for example, produce some dialogue on the screen, or give the player an item. When we interact with the teleport, we know we can move the player to some other location. And when we interact with a signpost, we display information. And the nice thing here is I don't need to code all of the special cases. All I need to do is provide the implementation for that particular object. And because all of these objects are fundamentally a dynamic object, I can store them all, regardless of their subtypes, in a single vector of dynamic objects. Which means all I need to do is call the onInteract function, and the compiler will sort out which particular onInteract code to execute.
And this is called polymorphism.
Which fundamentally means that all of these sort of leaf classes here, these are the main subclasses, share something in common. They share this interface, specified by Dynamic. Yet, how they implement that interface is up to the subclass. This will become quite apparent once we start coding things up.
Now, even though I've just shown that, we're really getting ahead of ourselves. Let's start with the basics. Let's take the platform game engine and convert it to something a bit more similar to what we want for this role-playing game.
And so here it is. This is the One Lone Coder platformer game code. I'll just run it to prove it, and it looks quite similar to the video that went out about this engine. And we're going to modify this to suit our role-playing game. After all, it handles all of the collisions between a dynamic object and the static background. And so the first thing I'm going to change is, of course, the name. And in keeping with the Nintendo Entertainment System resolution, I'm going to use a 256 by 240 array where the pixels are 4 by 4. We will want to make some significant alterations to this code. For example, the original map was stored as a big string. This isn't quite sufficient for a role-playing game. Firstly, there's a lot more tiles in the role-playing game than there is in Mario, so representing them all with characters becomes quite difficult. But also, there's not enough information captured here. It assumes that anything that is not the period symbol is solid, and that might not be the case for us. A typical example being that before we saw our player character walking across the grass and walking across the path, so there isn't enough information here. Additionally, editing these maps is quite tricky, because it's not a faithful visual representation of what the map will ultimately look like.
Also, right now, the level is part of the executable. And this does have some advantages. It can sort of be distributed as a single file, but it makes it quite tricky for the game design team to include their changes. So I think it's time that we start looking at the levels as being a separate file and a separate entity entirely.
And so I'm going to add an additional class, and we'll call it RPG Map. And this is an important moment for the One Lone Coder channel because this is the first time, I think, that we've done a project that's included multiple source files. So it's going to be a bit of a test for me to see how we navigate around all of this. I'm going to use the add class wizard just to add two files, a .h and a .cpp, called RPG Maps. And we can see now it's created two additional source files. However, I don't want a class called RPG Maps. I was just being lazy and using it as a way to create the file names. What I'm actually going to call it is CMap. And I'm going to use a lowercase c to indicate that this is a class. Now, of course, I'll need to change the names of the constructor and the destructor. We must also make sure to change these in the CPP file too. Now, I'm not a fan of using setters and getters everywhere, particularly for simple basic variables, so I'm not going to. In this case, so if I want the width and the height of the map, I'm just going to make them accessible directly by declaring them as public. I'm going to add a function which is getIndex, and this is going to return the tile index for a given location. Int x and int y. So the user will request a coordinate and it will return a single number which represents which tile to display out of the tile map that's been associated with this physical map. And we'll see a little bit more about that in a minute. But I also want another one, which is get whether the tile is solid or not. In this instance, I'm not creating the tile as a separate structure. It's really not necessary. But these two functions imply that I'm going to have a couple of arrays too, and I'm going to create these as private. And this means they won't be accessible to anything other than inside the CMap class. And so my physical map is going to be stored as an array of indices. And I'm just going to default that to null pointer. And we're also going to have a second array of booleans. We'll call that solids. There are some additional public variables that I'm also going to need. Firstly, I'd like to store the name of a map. So what map is this location? Is it the village 1? Is it a castle? What is it? And I'm also going to want a pointer to a One Lone Coder sprite, which you'll have seen in many of the previous videos. And this is going to be the imagery that is used to display inside the map. That's going to be a pointer to it, and we're just going to say p sprite. Now we can see that OLC sprite is not defined, and that's because it's part of the console game engine. So I'm going to include that up here so it gets defined. Now you'll notice that because of lots of bad practice reasons, by including this file, we've also just defined string, and that's because this header file uses using namespace std. You really shouldn't do it that way. But in this case, I'm going to justify it by simply saying I know I'm not going to be including any other package as part of this project. The final function I'm going to add is a create function, which takes a path to the external file containing the level data, the pointer to the sprite, and the friendly name, so it populates all of our internal variables. So let's give these functions some code. In the map CPP file, I'm going to just give all of my variables a default value. And whenever the map gets destroyed, I know that I've got two arrays, so I'm going to call the delete function to delete those arrays. For the getIndex function, I'm going to check that the requested coordinate is within the bounds of the map and return the appropriate index for the array. Or else I'm going to return 0. On the one hand, this means that the program will never crash, it won't access memory that it shouldn't, but on the other, it will give a graphical glitch if there has been something that's gone wrong, i.e. whatever tile is at index 0 will be displayed, and the game designers will probably quickly realise that things aren't looking the way they should. Another option is to return -1 here, but I don't know how that getIndex function will be used later down the line, and -1 probably isn't appropriate for indexing into a different array, so I'll return 0. And it goes without saying that the getSolid code looks exactly the same, except it indexes a different array. So let's consider the create function. Well, the first thing that will happen is we're going to store the name and the pointer to the sprite locally, so they're now part of the map class. However, we now need to load the file that contains the level data, and I'm going to use ifstream to do this. And to use ifstream, I need to include fstream. I think this is another first for the One Lone Coder channel, reading an external file. Well, it's always good to make sure that the file was opened correctly, so we know that the file name was given, was proper, so we can check using the isOpen function to see if that's true. If the file wasn't opened correctly, we can return false. So that gives some indication to the calling function that the file couldn't be found. But if we did read the file successfully, we're going to return true.
Now some of you may be sat screaming at your computers, no, 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 this is totally the wrong way to do this. And I agree. What we should really be doing is putting error checking in at fundamental levels, and I'm not going to do that because most of the video would then be about how do we do error checking. So I'm going to make some assumptions that my assets are in the correct format and named correctly. I feel that the code at the end of this will be more useful for study if it hasn't got all of the error checking stuff in.
Here I've got a text file full of numbers, and this represents a level. In this case, it's the single house village scene you saw at the start of this video. The first two numbers represent the width and the height of this area. And after the width and height have been declared, we've then got pairs of numbers which represent which graphic to use and whether or not the tile is solid. Now, in this case, that little village scene was surrounded by trees, and the tree is represented by graphics index 9. Let's just take a minute to look at a tile sheet. So a tile sheet is basically a One Lone Coder format sprite that contains all of the imagery required to assemble the map, and it's indexed by moving along and checking what its width is. So in this case, its width is 10 and it's 3 high. So index 0 is in this top corner that's left. So let's go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So index 9 is this tree.
And by the way, this sprite sheet was created by Tom L on the Discord server, and this sprite viewer is a really nice tool, was created by CrossX on the Discord server, so thank you very much for that.
And the sprite viewer is quite nice because it allows you to zoom in and out and see the sprites at an individual level, but also do some sort of analysis of what characters are there. So knowing that index 9 represents this tree, we can start to see that we've got a border of trees around the level. However, these trees are classified as not solid. Why is that? Well, let me introduce to you another tool. This tool was created by Ite from the Discord server, and it's a simple map editor for the role-playing game. And I just want to say this is a really good example of how the community is coming together to create utilities to support this project. Without them, it just would be simply too much work for me to do on my own in the timescales that I have available. And the sprite editor allows us to select sprites from the sheet that we saw before and place them around. So I can place trees anywhere in the scene, and we can assemble sort of interesting looking scenes. And we see at the top we've got the coordinate of the cell that we're interested in. Now, the file format we looked at before showed the row of trees with index 9, but it indicated that they weren't solid. The map editor will allow us to specify whether a tile is solid or not, and we can see by going into the solid tool we've got a little red rectangle in the top corner of each tile to indicate that it is solid. So in this case the building is solid, the trees that we've just placed aren't solid, and also you can see that the door here isn't solid either. That allows the player to step over the door. But this top row of trees is also not solid. I could make them solid, but I don't need to, because I know that surrounding the whole area is a solid wall. The player can't get through to it anyway. So that explains why our top row of the map doesn't have solid trees. So reading data using ifstream is quite easy. We can read the first two numbers simply by reading them directly into the width and height. Once we've done that, we can create our two arrays, solids and indices. And because we know the width and height now, we then just iterate through the whole file one element at a time, reading in the appropriate number into the appropriate array. So now we have our map base class. But individual maps in the game are going to be subclasses of this class. So let's create one for the first village. So I'll create a class that inherits publicly from CMap called village1. And don't forget your semicolons. And in the CPP file for the maps, now because we've derived the village class from the base map class, we just need to provide the constructor. And in this constructor we're going to call the create function. The first parameter is the path to the level file, so that was the file that contained all of the numbers we saw before. The second parameter is a pointer to an OLC sprite. Now the constructor for OLC sprite takes the path to the sprite sheet that we saw, which in this case is located at RPG Data, Graphics, and it's called Tom L Sprite Sheet Dark. The third parameter is the name of the area, and I'm going to call it Coda Town. Why not? And so in this simple little bit of code, we've created the whole map. And it's self-contained. We know that when village 1 comes into existence, it'll go and populate itself with the relevant data. So let's go back to our main program now and include our map class. So let's start making the relevant changes to get rid of the built-in map information to start using our external maps. And so I'm going to do that by creating a pointer of type CMap to store a current map. And I can do this. I don't need to make this pointer of type village1 because we're going to use the inheritance and polymorphic attributes of object-oriented programming to handle that for us. And Visual Studio is very kindly showing us now all of the things that are wrong with the code. So these are all of the locations that we need to modify to suit the new way of doing things. So the first change we need to make is looking at the collision detection. In the platform game, if the cell was anything other than a period symbol, it was considered solid. That's not the case anymore. Now, instead, we want to look at our current map, and we want to get whether that location is solid or not. So we're going to use our getSolid function. Of course, we don't need to check for this anymore. And so I can make all of these changes. Anywhere where we have a width and a height of the level, we also need to change too. So in this case, we can access these properties directly now. nWidth and nHeight. This was all of the code to handle the camera following the object on the screen. We don't need to change any of this, it's all completely valid. However, the way that we draw the map to the screen is now very different. We still need to get an index that represents the tile, and that returns a type int now, it's no longer a character. I'll call that index. But instead of this switch block, we want to calculate the x and y coordinates of that index in the sprite sheet. So to convert from a 1D to a 2D, usually we do it the other way around, we're going to use mod and div. So our sprite's x location, I'll say int sx, is equal to the linear index mod the number of tiles on our map, which I know in this case is 10.
I know, I'm putting in a hard number here. In a later video this will be updated.
And to get to the sprite tile's y position, we divide by 10. And it's important that this is all kept in the integer domain, because this will give us the row that the tile is on, because any information after the remainder of this divide is just lost, and this will give us the column that the sprite is on in the tile sheet. Now all we need to do is modify the drawPartialSprite function with the new parameters. So the X location is still the same, the tile width is still the same, the tile offset, none of that changes. However, the sprite does, so that's now currently stored as a pointer in our current map, pSprite. And the location, we're not specifying by hand anymore, we're going to use our new coordinates. And this is really nice because that means ultimately we can get rid of all of this, which makes our drawing routine much more compact. To debug this, let's initialize our pCurrentMap to be village 1. Let's compile. Oh dear, we've got our first set of problems.
Can you tell how this was all scripted?
If we look at the error information at the bottom, and I appreciate it's a bit small, fundamentally it says one or more multiply defined symbols found. And this is something we've always been able to avoid by doing things in a single file for the previous videos. We now need to think about things a bit differently. In fact, it's the console game engine itself which is causing the problem. And if we look at the console game engine code, right at the bottom we can see we've got three global variables which are used to handle the tidying up code when the user closes the application. Well, they're not strictly global, they're actually static variables that need to be defined somewhere. And the problem we've got here is that our main program is calling the OneLoneCoder console game engine file, but also our maps program is calling the file. So they're being defined twice.
And this is because in ordinary circumstances, CPP files only get compiled once by the compiler. But header files can be pulled in multiple times by whichever CPP file needs the stuff.
And things like this should be declared in a CPP file to ensure that it's only compiled once. So it's time to make the console game engine object-oriented programming proof. So I'm going to remove it. And I've already done this, it's actually not a big deal. I will add in what I've called OLC console game engine OOP. And what we'll see is it's exactly the same file with all of the same information in, except for when you get to the core engine file, it's now slightly called a different class, it's just got the prototypes for all of the functions. There is no body to it. And the static variables that were causing us problems before are declared in the header file, but they're not defined here, they're not given any substance. Instead, that's done in the CPP file, where the rest of the console game engine functions are also filled in. And this really has just been a cut and paste job. There is no difference to any of the internal code or workings. But at the bottom of the CPP file, we can see we've now got the definitions of the declared variables. So this means our main no longer inherits from the original console game engine, it's going to inherit from our object-oriented version. And we must also change in our maps.h file to include the object-oriented version too. And we can see now when we've compiled, there's not been a problem. We've only defined the symbols once. And you'll see that this is a common pattern in object-oriented programming, to have a header file and a CPP file, where it's important not to do too much in the header file, other than declare the things that you might want to use. So let's see what it looks like. Well, it's pulled in the map, that looks good, and we can see Jario from the platform game is still available, and he can stand on the trees, because if you remember, we didn't make all of the trees solid. So that means there should be an opening somewhere, I think, maybe not. So I can't actually get Jario into the world, but gravity is also still in effect, which is something we don't want. There we go. So the map routine is handling itself, it's drawing itself perfectly fine. Good.
But this brings about a secondary problem, and it's a slightly complicated one, and that's regarding asset management. Let's have a look at how we created that map in the first place.
To create the map, we created a class called Village1. Let's assume I wanted a second village called Village2. Fair enough. We go to our maps, and we go down to the constructor, where we'll create the definition for Village2. Assume there's a Village2 file, but I want to use the same sprite data. We can see here though that each village will reload the sprite data, and this is inefficient because I could have 20 or 30 villages in this game. I don't need 20 or 30 instances of the same sprite information. And just to make this even more different, we'll just call this Bugtown.
A better solution would be to load all of the assets we need once, and use the assets wherever we need them. And this means we need to break another rule of object-oriented programming. We're going to need to create a singleton.
I've added another class to the project called RPG Assets, and this is going to be a single location that's responsible for loading all of the artwork and extra information that we need for the game. I know that for a start we're going to be loading sprites, so we need the definition of the OLC sprite. But I want to make this class a singleton, which means the first time an instance of this class is created, it's going to load all of its resources, and they're going to remain persistent throughout the lifetime of the process. It is in effect one gigantic global variable. Now there are some quirks to a singleton. The first thing I'm going to need is a function so we can access an instance of itself, and this is where things start to get a bit weird. So I'll create a public static function which is called get, and that's going to return an instance to itself. And you can see it creates a static local variable in this case called me. And so once this is created, it remains persistent here. So it will always return the same reference to the variable me, which is of type RPG asset. So the first time this is called, it creates the instance, and then that instance remains persistent. To ensure that this does remain persistent, we need to do two more quite advanced things. The first thing I'm going to do is get rid of the default copy constructor that's created by the compiler. I don't want to create copies of this, because every time I do, it'll reload all of the assets again. So we'll get rid of the copy constructor. At the same time, I also want to get rid of the sort of load operator. In this case, it's equal. So if we were assigning an instance of this to something else, it would create a small copy of it. We don't want to do that for the same reasons. We've already loaded the sprites once. And this is quite a common pattern for declaring singletons. To make sure the user uses it as a singleton, we can get rid of the constructor by making it private. We might still want these things to execute, but it means the user won't be able to directly create an instance of this singleton. And as part of this singleton, I want to store a container that stores all of the sprites. And I'm going to use something we haven't used before on this channel. I'm going to use a map. And a map allows you to pair up a key with a value. And the type of the key is going to be a string, and the value in this case is going to be our pointer to a sprite. And we'll call this mmap_sprites. I'll need to include map at the top of the file.
A map is a little bit like an array, although far less efficient, but potentially a lot more useful. Instead of using numbers to index a location in that array, we can use other objects. And in this case, because I know that we're only going to be accessing sprites relatively infrequently, i.e. accessing the pointer of the sprite infrequently, that I don't need to worry about the performance hit that would involve. And the benefits I'm going to get from using a map here is I can use friendly naming conventions throughout the whole program, which means if I do end up having other people designing parts of this, they can stick to this friendly naming convention and the engine doesn't need to be altered.
And this may still seem all a little bit weird, but once I put this function in here, which is getSprite, you can see that we apply a name, and we're using the name as the index to the map. So it works in a very similar way to an array, but it's a lot more sophisticated. To our assets class, I'm also going to add a function which is loadSprites. So let's go and implement the body of this function. Here I've got the constructor and the destructor. And here I'm going to implement my loadSprites function. And this is where I want to do the single one-off load of everything that I'm going to need for the game. I'm going to start by defining a little lambda function called load, which takes a friendly name and the file name to the asset that we're trying to load. And in this lambda function, the first thing that happens is we create the OLC sprite using the file name. We get a pointer to it. And then I'm going to store in our map, using the friendly name as the index, that pointer. And the reason I want a load function like this is I can now easily load new resources. So for example, let's say we take our village map that we had before, I call load, and I'm going to create an asset which I'm just simply going to call village. And I'll pass to it the file path to the sprite sheet that represents all of the tiles. And that's all we need to do. So wherever we want to use the asset that represents this sprite sheet, we're just simply going to call our getSprite function with this friendly name. And so In this function, we can start to load all sorts of assets. We know they're only going to be loaded once. We'll need to load the assets at some point, so we'll go back to the main file now and include our assets class. I don't need to create an instance of it somewhere because it's a singleton. So I can go straight to the onUserCreate function, RPG assets. Remember, it's a method directly applied to the class in this case. We're going to get an instance of it, and we're going to load the sprites. So at that point, we have now loaded all of the artwork for our entire game.
I can get away with this because this is a small game. I can load everything at once. The memory footprint will be minimal. For really large projects, you probably do want something that's a little bit more sophisticated and loads things as and when they're needed.
My singleton has now loaded all of the sprites. For the time being, I'm going to leave in the Jaryo sprite because we'll handle that when we start looking at dynamic objects in the next video. But let's go back to our maps now. We no longer want to load the sprite here, instead we want to use our asset singleton. So in the maps header file, let's include our assets, and all we need to do here is instead of going directly to the file and creating a new instance, we can go to RPG assets, get an instance of it, and get the sprite, and we gave it the friendly name village. And that will return the pointer to the one instance of that sprite sheet that we've got in the game. We'll do the same for the other village. So we're no longer duplicating resources. We're coming up to the end of this video now, so I'm just going to make some tidy modifications to make it so we can move Jaryo around a little bit more sensibly. So let's take a look. So here we've got our map loaded in the background, we've got Jaryo, and we can move Jaryo around. He can't go over solid objects, he can fit into narrow gaps, and we know that all of our resources have been loaded in an efficient way.
I think we'll do one more thing before finishing this video, and that's showing larger text on the screen. You know that this is a console and displaying text is what it does naturally. However, at this resolution the text is very difficult to read. So instead, what we're going to do is create a sprite sheet of a font and display that font appropriately on the screen whenever we want to display text.
So using the sprite editor again, we can see I've created a sprite which is a font, and it's a font that's very faithful to the original Nintendo Entertainment System, where each character is an 8x8 array of pixels, black and white. And they're also stored in ASCII order. So A is 65 in decimal for capital A, so 66, 67, 68, etc, etc. And so the location of the index of this sprite ties into its ASCII location. And this is quite important. I'm going to add a function to the main class called drawBigText, which is going to take a string of text and a location of where to draw it on the screen. And in a similar way to drawing the map before, I'm going to iterate through all of the characters in the text using the ASCII value to give me an index position of where I can source the sprite from the sprite map. So it's exactly the same before. It's you choosing an SX and an SY value using mod and div, but in this case it's scaled appropriately according to the sprite sheet and for ASCII. So the sprite sheet really only started at ASCII character 32, even though that's in position 0. So that's why we've got a little offset there. And I'm going to draw the character using the draw partial sprite routine in the place specified by the X and Y coordinates. However, we've not got this sprite font variable, so let's add that in too. Gratuitously cut and paste here. But where do we load this? Well, of course it's loaded in our assets. If we go and have a look at the assets, we've got one that's friendly called font. Now you might think, do I access RPG assets and get an instance here? Well, no, because I'm going to be calling that a lot, and accessing a map does have a bit of a performance overhead. So because this is a variable that I'll be accessing very frequently, what I'm going to do instead is cache it, and that's why I've created a local variable here. So let's go to onUserCreate, and once we've loaded the assets, let's populate that font sprite variable. And it's RPG assets get the instance dot get sprite font. And it helps if you put a capital A at the start. And let's test this by, after drawing the player, let's draw some text on the screen somewhere. Draw big text, and we're going to pass the string hello everybody, and we'll draw that at location 30, 30. Let's take a look. And we can see we've now got big text on the screen, which is very readable for the player.
In this video we've looked at how we can load resources and make sure we've only got unique instances of those resources. We've considered how object-oriented programming is going to help us develop a rather complicated and large game engine. And we've looked at how do we partition the work between the programmer and the game designers. In the next video of this series we're going to start looking at the dynamic objects. How do we actually make the game a playable thing, and how do we coordinate the interactions between objects? As usual, if you've enjoyed this video, a big thumbs up please. Have a think about subscribing, because I think this series is going to yield a video that's really quite entertaining, and hopefully there might be a full game, and I'm really pleased that the community is showing a lot of interest too. So take care, and I'll see you next time.